Okay. Everybody's pretty much situated. All right, so today we're going to be talking about exponential and logarithmic graphs. On the back of the first page of the handout, you notice I've listed some properties of both graphs, including like what they should look like, the base function. So notice there's some information about the exponential graphs, the exponential functions. It has this general shape. You know, it's going up very fast to the right. The logarithmic graph is the inverse, so it has kind of the opposite shape. It's going really south to the left and out to the right. One thing I do want to point out is the domain of an exponential function is always going to be negative infinity to positive infinity if you just have a single x in the exponent. And that's switched for the logarithmic function. The range is negative infinity to positive infinity. It's because they're inverses, their domain and range is switched. Everything else can be transformed, so it's not set in stone. And we'll look at some of those. So the first one we're going to talk about is the top of the second page. Is we're going to graph f of x equal to 2 to the x power. Okay. What we're going to do is we're going to make a t-table. We're going to plug in some values for x to come up with some values for y. In general, what you want to do is use this kind of table, these values, to get a good set of points. So we want to figure out what 2 to the negative third is. What would that be? How would we figure that out? What does a negative exponent mean? 1 over 2 to the third, but what's 2/3 power? What's 2 to the third power? 8. So negative 3 would be 1/8. Let's plug negative 2 in. 2 to the negative 2 power, what would that be? Yeah. The negative just means we're going to invert it. And then 2 squared is 4. 2 to the negative 1 power. What do you think that would be? 1/2, right? 1 over 2 to the first, which is just 1/2. The rest of them are pretty easy to get. What's anything to the 0 power? 1. No matter what. 2 to the first, 2. 2 to the second, right, would be 4. And 2 to the third will end up being 8. So let's plot these points on our graph. Negative 3, 1, 2, 3. Positive 1/8, it's just barely above the x-axis. Negative 2, 1/4, once again just barely above the x-axis. Negative 1, 1/2. 0, 1, 1, 2, 2, 4, and 3. Sometimes the graph gets that big. Connect your points. And you have the shape of an exponential graph. Okay, so always have that basic shape. What would my domain be? All real numbers. And in interval notation, how would we write that? Right, and that's true. That's going to be true for any exponential function with just a single x. What would my range be? 0 to positive infinity, correct. It approaches 0, right? It keeps getting closer and closer and closer and closer, but it'll never be 0. There's no power of x we can plug in there that will give us a value of 0 for y. And it just keeps going up forever, so 0 to infinity. Do I have an x-intercept? No. It's not going to cross the x-axis. Y can't be 0, so there's no x-intercept. What's my y-intercept? Yeah, it is 1 as an ordered pair. I would write that as 0, 1. And I also have an asymptote. An asymptote is a line that the graph does not cross. So what doesn't the graph cross? What line? The x-axis, right? So as an equation, what would that be? Right. It's y equals 0, also known as the x-axis. Okay. So we're going to base our exponential functions. We're going to look at some transformations that we can do to this function, f of x equals 2 to the x, and see how we can just mess with the coordinates of our t-table to come up with the graph. All right, any questions on that one? All right, that's a pretty basic one. We're going to step it up, make it a little bit more complicated in a second. All right, can I erase some of this information? Okay. Okay. The next problem is, and I'm going to leave this one up here. Graph f of x equal to 2, x minus 3 plus 1 minus 1. Okay. What's the difference between this and this? What is going on? Just by looking at the equations. Right, there's negative 3 up here in the exponent, right? Right, and we have that negative 1. So what does this negative 3 represent? Yeah, it's a horizontal shift. So we're going to add 3 to our x values, right? Because we're going in the horizontal direction. All right. What else is going on? All right, we have a vertical shift as well. A vertical shift. And that one we take the actual value of it. It's minus 1. So we're going to subtract 1 to our y values. Our parent function was this one. F of x equals 2 to the x. I have the same base. We're just transforming it through a horizontal and vertical shift. I need to add 3 to my x values and subtract 1 from my y values. So if I add 3 to my y values, start here, what's negative 3 plus 3? 0. Negative 2 plus 3? 1. Negative 1 plus 3? 2. And if we keep adding 3 to all of these, you're going to get 3, 4, 5, and 6. Everybody agree with that? Just adding 3 to our x values. Now if we subtract 1 from our y values, a little bit more difficult. So 1/8 minus 1, you can do it in a calculator or by hand. Minus 1. Since we're subtracting with fractions, we need a common denominator. So what would the common denominator be? 8, thank you. So 1/8 minus 8 over 8. So what's 1/8 minus 8 over 8? Negative 7 over 8. And we have to do that for each one of these. 1/4 minus 1. What's the common denominator there? 4. So what's 1/4 minus 4 over 4? Negative 3/4. 1/2 minus 1, you do that, you're going to end up with negative 1/2. 1 minus 1, 0. 2 minus 1, 1. 4 minus 1, 3. 8 minus 1, 7. So there's our new table of values using the transformations that happened in the graph. We had a horizontal shift and a vertical shift. We applied both of them. So let's graph and see if we ended up with the same shape, just shifted. So 0, negative 7/8. That'll be right about here. 1 and negative 3/4. Right about there. 2, negative 1/2. 3, 0, 4, 1, 5, 3, and 6, 2, 4, 6, 7. They're all right there. Okay. So did we end up with the same shape? Minus my poor graphing. Did we end up with the same shape? It was just shifted 3 to the right. All the points were shifted 3 to the right and down 1. So the graph itself looks the same. It's just shifted. So let's talk about some of this information. What would the domain be? Yeah, we still have that negative infinity to positive infinity, all real numbers. That's not changing. But the range changed. What do you think the range would be on this one? Negative 1. We had a vertical shift down 1, which means that asymptote also shifted down 1. So we'll keep that in mind. So our range would be negative 1 to infinity. Do we have an x-intercept? Yep. 3, 0. We have a y-intercept. Right. 0, negative 7/8, right? If you're having trouble seeing it on the graph, you should have it also in your table. And an asymptote. What do you think that asymptote is now? Y equals negative 1. Yep. So notice on the last one, the asymptote was our x-axis, but because we shifted down 1 in this case, our asymptote also shifted. Okay. Any questions on that one? So we're just using the parent graph and using transformations from our original xy table to come up with a new set of points. Right. So did we need to use a graphing calculator at all on that one? No? Right. We don't always have to depend on it. All right, can I erase what we just did and move on to the next one? Yes? All right, so there's a lot going on with this one. What do you think's going on with that one? Would it help to rewrite it? Would it make it a little bit easier to see? This 5 back here is being in addition to. So let's rewrite it. Does that mean the same thing? Did I change anything except the order? No, still have a negative x. Still a positive 1. That's still a positive 5. That's still a negative in front of our base of 2. So what is going on this one? What kind of transformations and shifts we have going on? Okay, I agree. The vertical shift is the last thing we need to do. So I'll put that down here. So we're going to add 5 to our y values. There's a reflection. Wouldn't it be both? We have a negative in front of our x in the exponent, and we also have a negative in front of our base. So there's going to be a reflection over both axes. So there's going to be a reflection over the x-axis. That's taken care of by that negative. The other negative is a reflection over the y-axis. What else is going on?
Subtract 1 to the x value?
Yes. We also have a horizontal shift. This plus 1, so that's a horizontal shift. And for horizontal shifts, we take the opposite of that number. So minus 1 to our x values. For reflections over the x and y axis, yeah, sure.
Is there a particular order?
Yes. That's why I put them in this order. All right, the horizontal shift, you need to do that first. Any reflections come second. Vertical shifts are at the end. For reflections over the x and y axis, all you have to do is multiply them by negative 1. So this would be negative 1 times your y values for reflection over the y-axis. For the reflection over the y-axis, it would be negative 1 times your x values. So let's do all these transformations, these shifts, these reflections, and when we get to our table over here, that's when we can get to a point where we can actually plot it. So if I'm going to take away 1 from my x values, I'm just going to subtract 1 from all the x values in this column. So if I do that, that's going to be negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. Just taking 1 away from all my x values. This horizontal shift, did it affect my y values at all? No, right? It's a horizontal shift, not vertical. So for this table, I'm just going to rewrite my y values. Half. My reflections, I'm just going to be multiplying my x and y values by negative 1. Could I take care of both of those at the same time? Yes, right? I'm just going to take my two columns and basically just change the signs on them. That's what a reflection is. So if I change the signs on my x column, I get 4, 3, 2, 1, 0, -1, -2. If I multiply my y values by -1, it's just going to change the signs. -1/8, -1/4, -1/2, -1, -2, -4, and -8. Only have one more transformation left. That's the vertical shift. I need to add 5 to my y values. Is that affecting my x values at all? No. That vertical shift is only going to be in the y direction. So I'm just going to copy down my x values. So we're going to need to add 5 to all those y values. So if I add 5 minus 1/8, we're going to do what we did earlier with common denominators. Has anybody figured that out yet? You guys waiting on me to do that? So -1/8 plus 5, how would I work that out?
You use 40.
Yeah. Yeah, we will eventually get 40. Need to multiply 5 over 1 times 8 over 8. You will end up with 40, correct? -1 plus 40 is 39 over 8. The next one was we're taking 5, -1/4, and adding 5.
-1/4?
Yes. This -1/4 right here. So -1/4 plus 5. What would our common denominator for that one be? Yeah, I heard a mumbled 4, so I'm going to do that. So 5 times 4 is 20. So what is -1/4 plus 20/4? 19 over 4, correct. -1/2 plus 5. Work through the same steps. You end up with 4.5, which is 9. 9 over 2 eventually. Rest of them are a little bit easier, right? We don't have to deal with fractions. -1 plus 5 is 4. -2 plus 5 is 3. -4 plus 5 is 1. -8 plus 5, -3. So all those transformations to get us a new t-table. So let's graph this. Some of these fractions are easier to think about as mixed numbers, because 39 over 8 sometimes is hard to picture where that's going to fall. But 39 over 8 as a mixed number would be what? How many times does 8 go into 39?
4 and 7.
Yeah, 4 and 7/8. 19 over 4. 4 and 3/4. 9 over 2. Yeah, 4.5. All right, a little bit easier to visualize on the graph than improper fractions. So 4 and 4 and 7/8 would be up here, roughly. 3 and 4 and 3/4 would be 2 and 4.5. 4.5. 1 and 4. 0 and 3. -1 and 1. And -2 and -3. So let's connect those points. Do we have the same basic shape of an exponential graph? Yeah. It's just twisted, right? We had a lot going on that one. We had it shifted -1 to the left. We had a reflection over the x and y axis, and we also had a vertical shift. So the same basic shape is there. It's just in a different place. Where would my asymptote be on that one? Any ideas? What was our vertical shift? What was the vertical shift on that one? Yeah, right here, right? +5. So 1, 2, 3, 4, 5. That was a better artist. All right, so there's our asymptote. So let's talk about some information about it so we can fill in those blanks on there. Once again, what would my domain be? All real numbers. What would my range be? Be careful. Close. Correct. Because remember, it has to go from bottom to top. So -infinity to 5. We had a reflection over the x-axis, so it's going to switch. Notice it's going forever down, and then it's getting close to this asymptote, but never approaching it. So the range is always read from bottom to top, so our range would be -infinity to 5. What would our x-intercept be? Was there an x-intercept? Yeah, it does cross the x-axis. Yeah. Yeah, it's going to be an estimate. We'd have to go into a table and figure that out, or plug in 0 and solve it. We don't really have time for that. So our x-intercept is going to be an approximation. It's going to be roughly, was it -1.5-ish? And then our y-intercept, did we have an x value of 0 in our table? Yeah. So our y-intercept would have been 0, 0, 3. Okay. All right, so that's taking a parent exponential function and applying a lot of transformations to it. But once again, once you figure out what the transformations are, the rest of it's just arithmetic. Right? You're just adding and subtracting and multiplying. Any questions on this? Because after this, we're going to move to logarithmic graphs and show you the difference between the two. Any questions? No? Okay, so I'm going to erase a whole lot of stuff and come on back. So now we're going to graph log base 2 of x. What this really means is y equals log 2x. So 2 to the y equals x. Transferring from logarithmic to exponential, 2 to this power has to equal x. So do you agree now that x depends on what y is? Right? Because we can plug in something in for y and get our answers for x. So instead of plugging that negative 3 to 3 in for x, for exponentials, we're going to plug it in for y. So what were these values again? Because they're going to be exactly the same as they were for 2 to the x. They're just going to be in place of x instead of y. So 2 to the negative third power, 1/8. 2 to the negative 2 power, 1/4. 2 to the negative 1, 2 to the 0, 1, 2, 4, 8. The same table as exponential, it's just reversed. And that's because they're inverses of one another. So let's move to our graph over here. 1/8, just barely passed, and then down 3, right here. 1/4, down 2. 1/2, down 1. 1, 0. 2, 1. 4, 2. 8, 3. Right. So we get that shape. Looks like an exponential, just going a different direction, right? Same basic shape, just transformed 90 degrees the other way. So what would my domain be? Yep, 0 to infinity. Well, remember when y equaled 2 to the x, that was the range, right? They were switched. So what would the range on this one be? All real numbers. Right, it's going forever down. And this is going off to the right, but as it's doing that, it's going up. So negative infinity to positive infinity for the range. Do I have an x-intercept? 1, 0. Do I have a y-intercept? Nope. What's my asymptote on this one? X equals 1 would be right here, but it looks like we have a point there. X equals 0, correct. X equals 0, also known as the y-axis. So the very first problem we did, y equal to 2 to the x power, everything was switched, right? The domain and range were exactly the opposite. The x and y-intercept were exactly the opposite. The asymptote was the x-axis. This one's the y-axis. So the two are inverses of each other, which means their x and y components are switched. All right, so that's the parent function we're going to be using for logarithm. So let's do some transformations to these. Any questions on that one? Okay, so I'm going to leave the parent function up there. And we're going to talk about this next one. F of x equals negative log So what kind of transformations are going on with this one? There's vertical and horizontal shifts. I agree with that. Horizontal shifts. Yes. Reflection. Over x-axis. What's the horizontal shift? Left 3. We have a positive 3 in with the x. So it's negative 3 to our x values. And someone also mentioned we have a vertical shift. What's our vertical shift? Yeah, negative 2, right? Start at the end. So negative 2 to our y values. So this reflection over the x-axis, we need to multiply negative 1 times which values? If we're reflecting over the x-axis, because that negative in front is a reflection over the x-axis. So which values are we going to multiply by negative 1? My x values or my y values, if I'm reflecting over the x-axis. Why? And if I'm reflecting over the x-axis, if I have a positive 3, I have to change the sign on my y values to reflect over the x-axis. So let's do these transformations. I'm going to subtract 3 from all my x values. Okay. So negative 3 plus 1/8. Someone work that out for me, see what you get. You can do fractions, I promise. Thank you. Negative 23 over 8. Negative 3 plus 1/4. Thank you. Negative 3 plus 1/2. Negative 5/2. Right. And then negative 3 to these values. A little bit easier, they're whole numbers. So 1 and negative 3. Negative 2. Negative 5. Negative, oh wait a minute, I'm screwed up there. If I subtract 3 from 2, I get negative 1. 4 minus 3 is 1. 8 minus 3 is 5. Is that horizontal shift going to affect my y values at all? Nope. The horizontal shift is strictly x values. So my y values for this transformation are staying the same. So all we did there is we subtracted 3 from all of our x values. To take care of the reflection over the x-axis, I'm just multiplying my y values by negative 1. So if I multiply my y values by negative 1, what would my new y values be from top to bottom here? 3, 2, 1. Right, just switches the signs. Just change the sign on all your y values. That takes care of that reflection. There wasn't a reflection over the y-axis, so I'm not going to change my x values at all. They're staying the same. One more transformation, vertical shift. I'm subtracting 2 from all of my y values now. So starting with 3, 3 minus 2 is 1, 2 minus 2, 0, 1 minus 2, and keep on going. So negative 2, negative 3, negative 4, and negative 5. The vertical shift does not affect my x values. So those are going to stay the same for that transformation. Once we've gone through all of our transformations, we're going to plot all of those points. Once again, mixed numbers, easier to deal with than improper. So negative 23 over 8, what's 23 over 8? What does that convert to? Right. So negative 2 and 7/8. Negative 11/4, using the same thing, be negative 2 and 3/4. Negative 5 over 2, negative 2.5. Okay. So let's plot these new points and see what our graph looks like. Once again, it should be the same kind of shape, just in a different location. So negative 2 and 7/8 be very close to negative 3, and then up 1. So right about there. Negative 2 and 3/4, and 0. Roughly right about there. Negative 2.5, and negative 1. Negative 2 and negative 2. Negative 1 and negative 3. One and negative 4. And 5 and negative 5. Same shape, just in a different part of the graph. Okay, so what's some information we can derive from that? What would my domain be? Negative 3 to infinity, right? Well, draw this a little bit better. Because originally our asymptote was the y-axis, but remember that we shifted left 3, so our asymptote also shifted to the left 3. So our domain shifts to negative 3 comma infinity. What would my range be? Yep. For logarithmic, that's always going to be the case. Negative infinity to positive infinity. Do I have an x-intercept? I do. It's the value. That's where y is 0. The y-intercept is a little bit more difficult. Do you agree? Yeah, on that one, we'd have to do some work to solve it. So what's a good estimate about where it would be? 3.5-ish. So 0 and negative 3.5-ish. And our asymptote? Yep. It's a vertical line now, so x equals -3. Any questions on that? Yeah, I have one more, and that one we might have to, I lied about the whole calculator thing. We might need a calculator for that one. Okay. Can I erase this information? Yes. This last one says we have ln x, which is the natural log of x, minus 2. What is the base on a natural log? E. So let's talk about just y equal to natural log of x. It's understood to be a base of e. So what we're looking at is e to the y power equals x. Once again, and just for time's sake, just going to plug in these values. Once again, x depends on what y is, so we're going to plug in our values for y. So e to the -2 power, once again, means 1 over e squared. So we need to use our calculator for that. So in your calculator, you're going to put e and then raise to the -2 power. Anybody have that? Just a, no, it won't be a fraction. It should be a decimal.
Oh,
0.135. Okay. The next one would be e to the -1st power, which is the same thing as 1 over e. But in your calculator, you can just put e to the -1 power. Should be like 0.4 or something. 0.368. Once again, these are approximations. E to the 0 power, well, that one's easy, right? Anything in the 0 power is 1. E to the 1st power just means e raised to the 1st. Should be 2.7 something. 2.713. 2.71. That last one, e squared. Just type that in your calculator, e to the 2nd power. 7.39. So let's take those values and plot it. Once again, those are decimal approximations. So 0.135 just barely passed the origin, down 2. 0.368, about a third of the way, down 1. 1, 0. 2.71, almost a 3, up 1. And then 7.39, 3, 4, 5, 6, 7, and 2. So do we still get that basic logarithmic shape? Right? It was a natural log. Right? But it still had a base of e, but the shape is going to be that same basic logarithmic shape. This one had a shift. Had a vertical shift. Down to -2 to the y values. So using our same parent function, these values, let's subtract 2 from our y values. -2 minus 2. Let's go -4. Oh, yeah, I like -4 better. -1, -2, -1 and -2. -3. 0 minus 2 is -2. 1 minus 2, -1. 2 minus 2 is 0. Is that vertical shift affecting any of my x values? No. They're going to stay the same. So 0.135, 0.368, 1, 2.71, 7.39. Let's take those values now and plot them. 0.135, -4. Let me do it in a different color. 0.135 down 4. 3.68 down 3. 1, -2. 2.71 minus 1. And 7.39, 0. Right. Same graph, everything was just shifted down 2 places though, right? That was the only thing that was going on. So our points were just shifted down 2. What would my domain be? 0 to infinity, right? We didn't shift to the left or right at all, so the domain would have to stay the same for any logarithmic. What would my range be? That's the same for any logarithmic. X-intercept. Do we have an x-intercept? Yeah, we have a y value of 0 here. Yeah, 7.39, which was e squared, right? So e squared, 0. Y-intercept. Did we have a y-intercept? No. Because the y-axis ends up being our asymptote. And our asymptote, what would the equation of that line be? It's the y-axis. But what's the equation of a line that is the y-axis? X equals 0. And that would be information for that. Okay? So really the only thing we needed our calculator for is to figure out values of E and to do some arithmetic. Everything else can be done by hand. All right? If you have a chance, please fill out the evaluations and turn them in face down.